last day of the Spinnaker Summit. Thank you for being here this morning. I really appreciate it. About 3 months ago, I was speaking to an executive at JP Chase, and in this room, it's myself and 3 other executives from Armory, and we are selling Spinnaker. We're going through the features, telling her about blue-green, canary, and rollbacks, all the things that you would expect when you talk about Spinnaker. And as I'm going through that, she interrupts me and she says something to me that I just didn't really expect for her to say, which she said, while Spinnaker is a great piece of technology, the reason we are standardizing on Spinnaker and we are supporting Spinnaker is because of the people and the community. And I absolutely love that response. And what it means is really that she is choosing Spinnaker because of all the people in this room, not just the contributors and people who write code, but also the users, the evangelists, the people who write documentation, Pete, who helped put this whole summit together, and everybody who supports Spinnaker in their own way. And I just thought that was absolutely fantastic. And that is why we're all here today. Really, if you think about the Spinnaker Summit, it is a celebration of the community. It is a celebration of everything that we've done this year. And it's also an opportunity for us to align together about what we're going to do next year. So here are some of the contributors, some of the world's largest cloud providers contributing code to Spinnaker. So who knows Kubernetes better than Google? Who knows Lambda and ECS better than Amazon? Nobody does. This is what sets us apart. We have the world's best cloud engineers contributing to Spinnaker. But we also have some of the world's best users, most progressive users using Spinnaker, right? They are dealing with challenges at massive scale. And while those challenges are complex and important, what I really love about our users and our community is actually the compassion that you guys show to each other every single day in Slack. And I see it. None of you have to help each other, but you do. You help each other through those problems that you've experienced before, because there's no way the core set of just contributors can support the massive set of users that are using Spinnaker, and I love that. You also show up to SIG meetings to give feedback. You issue a lot of bug reports, which is great, so we can fix them. You issue new RFCs, new ideas to help us understand what it is you need in order to be successful with Spinnaker. So this is a quote by a famous management consultant named Pere Drucker. He has many books out. I'm sure some of you have probably read some of his books. And what he's saying here is culture eats strategy for breakfast. And what that means to me, really, is that anybody can copy our features. And they're open source. You can literally copy and paste our features and put them somewhere else. Anybody can copy our roadmap. Our roadmap is publicly available for you to see exactly what we're going to build next. But what you can't copy and you can't take from us is our culture. It's our community, the things that we stand for, our values. That is what is unique to us, and you can't take that from us. So, what is our culture? And before we talk about our culture, let's talk about culture in general. So what is culture? Culture is something that you can't really touch, but you can feel it. So let me ask you guys, has anybody been part of a toxic culture? Just raise your hand. Right. Now, the thing about that, most of you raise your hand, and if you didn't raise your hand, that's good. The thing about that is that nobody intends to build a toxic culture. It's actually the lack of intention that results in a toxic culture. And so we as a community, we want to be intentional about the community and the cultural values that we're building. And what culture means to us is how we work together, how we make decisions when difficult and challenging problems arise. It's also how we come together and how we show up for each other. Oh, I got it there. Nice. So a while back, when we first started Armory, I asked Andy why he chose to open source Spinnaker at Netflix. And one of the things he said to me was that Netflix could actually learn faster and bring in the learnings from the community than doing it on their own. right? He valued the openness that was out there, and he said we could do this better together. And that was pretty brave, because he had to actually open source some proprietary technology to Netflix that competitors were eventually going to get a hold of. But really what this meant, what this prioritized for us, is learning, and that we're better together than we are apart. We also believe in learning moments. So I was originally going to title this slide, Failure is Okay, but I realized that failure is actually only a failure if you don't take the opportunity to learn. And so I changed this to learning moments, and I think that's really what we're about, right? We're about minimizing the impact of accidents and learning from them so that we can iterate and quickly move, right? Reducing catastrophic failures and moving into things like fender benders so we can not be stopped by crazy errors in production. So we also need to talk about the things that we aren't and the things that we don't value. Culture also encompasses that. And it reminded me of the stoplight. Now, stoplight also has really good intention, but it has some serious flaws. For example, 15% of all fatalities on the road happen at an intersection with a stoplight. It also has a hard dependency on electricity. When electricity is out, it no longer works. It also has to have perfect timing. If the timing is off by just a little bit, serious problems could arise. And worse yet, it actually incentivizes us to do the wrong thing. Who's actually stood up at a yellow light? If you didn't raise your hand, you're a liar. And even the slightest distraction could cause catastrophic results. And the basic assumption of a traffic light is that you cannot be trusted. That somebody else is going to be making those decisions for you based on static context. And we believe that there's a better way and a better analogy for who we are, which is a roundabout. A roundabout actually puts the emphasis and the responsibility of the drivers to merge in and out. There's no dependency on electricity, it's just a circle. The timing, there's no centralized timing, it's all decentralized to the drivers. The drivers are making the decision in real time based on the conditions on the road. So it's based on some loose rules. We empower the people on the road to make those decisions. It accounts for any road conditions, pedestrians, anything that's out there, people riding bikes. Again, when you empower the driver, right, we can let go of all these other things like electricity and centralized timing. It actually incentivizes you to do the right thing. When you enter a roundabout, you don't speed up like you do with a yellow light. You enter with safety and intent. You're aware. And the basic assumption here is that you are to be trusted. This is something that Andy's talked a lot about, which is context over control. And we want to empower these developers with information. We want to empower drivers with information to let them make the right decision. We don't want to take those rights away from you. We also believe in safety. So in 1930, we introduced seatbelts, and in 1985, we also made them mandatory. And in both of those times, accidents actually went up, not down. And it was really interesting to me to figure out what was happening in this time. And what was happening was that while accidents went up, there were minor accidents. There were fender benders. But what went way down were catastrophic events. Failures, deaths, fatalities. So we injected safety. And what ended up happening was we got psychological safety, we have physical safety, and we ended up driving faster. We got from point A to point B faster. And that's ultimately what we want. And absolutely we're going to get into some accidents, but it's okay as long as they're minor accidents and fender benders. So one of the things that we firmly believe in is that safety enables velocity, and that we're not choosing between the two. This is another thing that you'll hear Andy say a lot, guardrails over gates. And the reason this is important is the guardrails kind of tell us the best known path to date, right? But we don't want to enforce the fact that we know best. We know that as our context and our situations change, as we learn, we're going to want to change this. But how do we learn? We learn by experimenting, we learn by moving off the best practice path. We try new things. And if we are enforcing what we know, then we don't ever try new things. And this is really important for us to have as a value. And all of these values are actually embodied in Spinnaker, and you'll see them throughout the product. We give you context, so you have information about what's running in production, what versions are there, what container version is there, load balancer, services, security, networking. We'll tell you how that code got there in the first place, who deployed it, when it was deployed, what triggered it, what system sent it, what Git hash is there. We also have the guardrails, which are these deployment windows. And it doesn't stop you from deploying into production. It'll inform you that this is probably not the best time to deploy Friday night at 6 p.m. But if you need to, in case of emergency, you will. We also have these happy little accidents in production that we can call canarying, right? Trying things out in production is okay, as long as they're not catastrophic events. We also integrate with Chaos Monkey. We have resiliency. It's something that we absolutely care about. And in that roundabout example, really it's a resilient system. Regardless of the conditions, the drivers adapt to the situation. So what do we believe in? We believe in empowering developers, that you trust your developers to make the right decision. That we are not choosing between safety and velocity. Safety enables velocity. Context over control, that we will give you information for you, the driver, to make the right decision. Guardrails over gates, because we want to empower people to innovate and try new things. We want to minimize catastrophic events, but we don't want to avoid them altogether. We want to make sure that we're doing things safely. And we want to focus on things like resiliency. We want to iterate and learn and inject errors and see how we react to them. So this creates a flywheel effect. And this flywheel effect that we have in our community is embodied in our opinionated platform that we call Spinnaker. That is consumed by enterprises and businesses that also help them go through this transformation and change that our entire industry is going through right now. As they learn and as they gain value from Spinnaker and they see their companies change, they'll join our community too. And we'll grow and we'll scale, and that will have our values in the community adapt. And around we go. And the thing about a flywheel is that you can actually invest in any area of the flywheel and it'll actually make it go faster. And once a flywheel has momentum, it's really, really hard to stop. And that is what we're building. And I've seen this for the last 3 years in this summit. As we continue to grow, our values continue to deepen, we continue to learn faster than anybody else. I also wanted to give thanks to the Technical Oversight Committee. So if you're one of these 5 people, could you please stand up? I know Ethan is here. Let's give him a round of applause. And let me tell you why we give them a round of applause. Because they are the ones that have to take all of the values that we want to have in the community and actually put it into practice. And believe it or not, it's actually hard to get Google, Netflix, Amazon, and Armory to all do the same thing and go in the same direction. And it's not easy. And so I'm very appreciative of these people who are doing work every single day to make sure that we are all working well together and that we all embody these values. So I want to end on this. So there's this moment, this really beautiful moment that happens in humanity. It's, you're on the road, you're in the car, and you hear the sirens coming. It's going, and you look in your rearview mirror, and cars start to part ways. And then, of course, you part ways. You go into the shoulder lane. And in that moment, when that ambulance is speeding by, what we've done is that we've put the needs of somebody else above our own. We've collectively created this path for this ambulance to go on by. And this, I believe, is what we need more of in our community. We need to elevate our community above the needs of our own. And the more we do that, the stronger our community will be, because ultimately, what sets Spinnaker and our community apart from anybody else is us. And the stronger that we are, and the better that we are, the better Spinnaker and the community will be. So thank you.
Good morning, everyone. My name is Michael Benedict, and I'm here to talk about CI/CD at Pinterest. Something about me, I lead the engineering productivity organization at Pinterest. And we have one thing. Our goal is to help make our developers extremely productive, happy, and really love their job. This is my Pinterest board. And I think before I start, who hasn't heard about Pinterest? Okay, so that's really good. Otherwise, I was going to do a product pitch over there for Pinterest. Anyway, so Pinterest, just to reiterate, our mission is one thing. We want to bring everyone the inspiration to create a life they love. And to be more specific, we want to help people really discover new things and really pursue that outside the norms of your screen or your application. For example, I'm wearing these amazing Nikes today, which very much resonates with the colors over here. And I actually have a Pinterest board collection of multiple shoes, which my wife is not particularly very happy about. But then again, just to give you context on how large Pinterest really is, we serve more than 320 million users across the globe. And Pinterest collectively holds over 200 billion pins. Pins is basically an equivalent of, say, a tweet in Twitter or a post in any other social media. The thing is, the most important aspect of that is it's all human curated. Like, people have actually taken the extra step to pin something. It could be an image, a link, a video, and actually categorize it or provide annotations which provide these amazing visual graphs of what someone could really like and what could they get inspired with. With that, obviously our job is to provide amazing, delightful experiences to our pinners, and that means my team's job is to make sure every engineer in the company is, again, very productive. And this is our vision. Our job is to provide a fast, safe, and a delightful path to take an idea to production. And the key thing to note over there is we don't want anyone to worry about infrastructure. With that, let me tell you a story about continuous delivery and how Pinterest really moved from what it used to do today, previously, in terms of deploying to machines one by one, to right now fully embracing the continuous integration and delivery platform. I think TLDR, this was the process. We were basically laying tracks as we were moving fast. And definitely I could end the keynote right now, but I think I really want to give you the complexity, how hard this is. And just to reiterate, this is really not a technical challenge, and that's what really I'm here to talk about. It's more of a process challenge. So before I get started, this is kind of the Pinterest's left side of the brain and the right side of the brain, the analytics side of the stack, and the serving side of the stack. And the reason I wanted to show this is it was really important for us to first understand like where the problem really lies, and then focus on that particular problem to solve. To give you a footprint of how large our infrastructure is, it's pretty large, so I won't really go through the numbers since it's there. But then let me come back to helping define the problem. How does the architecture play a role with our footprint, and how we decided to solve this, how did we decide to solve a particular problem? So, going back to our architecture diagram, we realized that Pinterest, again, runs one of the largest monoliths. We are big on Python. So our serving stack, which is at the top right there, our API service and our web service, both of them are still on their monolithic Python service graph. And to just give you a perspective on how large that is, we actually have more than 200 plus engineers committing code to just those two systems. We see more than 3,500 commits a month, and it runs over 5,000 servers. So it's a pretty large system. And that really helped us focus. We realized that if we could unlock value for those many engineers who are shipping these amazing features for Pinterest pinners, that would be the biggest value add to show the organization on how we can really move fast. So we pinpointed to a particular service, a particular system, and we took that as the larger problem domain. And we started going deep down into truly understanding how things were happening for that platform. And yes, it's a long list of challenges. I'm just calling out the top 10, but there are definitely more than that. But to be honest, at a high level, one of the key things which was plaguing us in the past is deployments were extremely manual. We would actually do deployments twice a day, scheduled at 10 a.m. and 2 p.m. And rest assured, never was that schedule adhered. We would never get a deploy out because there were so many commits going out, there were so many users trying to push their changes out, it was extremely hard. And just to get a sense of why that was the case, we did our full analysis and trying to understand the problem statement, and this is what we came up with. With that, once we understood what the problem was, the next step is to define what is your success criteria. How do you actually convince people that, okay, here's definitely a problem, but how do you measure success? So that's the next thing we start focusing on. We start focusing on 3 particular pillars. So one is velocity. We started understanding metrics on how long does it take a developer to ship code from an idea to production. The second one is about quality. How quickly can you find bad code before it gets deployed to production? And finally, reliability. How often does bad code get deployed and has a significant impact on our business metrics? Obviously, it's very hard to kind of put all these metrics together and come up with one single metric, but we were pretty close, I felt like, because we came up with this one release SLO, the P90 time which it takes from commit land to deploy. And I'm just speaking about more about that later. So the next step, iterating on the experience. Now that we have the problem domain, we have our success metric, we haven't still figured out what is the right number there. Let's understand how we can go about defining that number through iterating through the experience. This is how it started. This is the first variation of how we started doing CI/CD at Pinterest. We said that we were going to start deploying 9:30 a.m. We're going to continuously try deploying this manually until 5 p.m. end of day. And you can see me actually typing one of the first commands. And this is how it goes through on a day-to-day basis. Not even day-to-day, actually hour-by-hour basis. I was doing this every day. Not only me, obviously, it was a collection of on-call engineers, and clearly they would hate me for this. But this is what every day they were doing to emulate what continuous delivery actually means. And yes, it's a very hard process. And you can see there's my tech lead actually posting the end of day deploy status. So we got from 1 or 2 successful deploys to 4 successful deploys on one of our services and 0 on the other. Another one, again, we're making some progress, but we started determining failures. And finally, we were so happy when we managed to get like 3 to 5 deploys a day. It was insane. And you can see the number of kudos right there at the bottom just to get that out. And yes, it was so manual, but that really helped us understand what we should automate on. What should we focus on? So overall, yes, there's a process of going from code, test, build, deploy, delivery, and operations. So we did determine that there are key areas in each of these specific pillars to automate and focus on. That's what I'm pretty much highlighting over here. Like for example, it's a no-brainer that you have to do a PR validation before you actually push it to master. But yes, we actually have the data to back that up as to how often does it break because of that. We decided that we absolutely need a golden test suite of tests and with very precise owners so that we can actually go ahead and block releases if something fails. Improve the build, reduce the build complexity while improving the build times. We also realized that there's a need for asynchronous pipelines and obviously canary analysis to make sure that we can automate the whole rollout process. And finally, you want to fail fast and you want to make sure that you can roll back or remediate any sort of reliability issues on production. And yes, obviously pipelines was a big thing. This is my first slide on Spinnaker right now throughout my talk, but clearly this enabled us to do most of that. We started orchestrating our CI/CD process into actual stages and pipelines. One example is just on the top, the global continuous deployment pipeline. And there's a very specific one you can see at the bottom, where we provided our service owners the flexibility to add certain stages and experiences as part of the rollout process. TLDR, we actually moved from that world where we would end up doing hundreds of commit changes in a single deploy to what's happening today. 9 to 5 continuously, Pinterest is being deployed as you can see over there, we worked on that particular experience where now we're shipping like 3 commits, 4 commits on every deploy. And even if there's a failure, at the best, we're going back only by 3 commits, which is insane. And finally, measure. I think this is the best graph to show. Like I always show this to all the customers and even the executives at Pinterest. And you can really see where the inflection point is. The blue line basically shows you the P90 time, which takes from launch to commit, and how it drastically reduced while the number of deployments increased. And that's why we introduced Spinnaker, right? Like you can start seeing the number of deploys really go up. And to give you a perspective, we actually do more than 25 deploys a day, continuously from 9 to 5, and the P90 time on those commits are actually under 4 hours. There are testimonials from users who say, I just commit and I forget about it because I know within a certain amount of hours that's going to be shipped to our pinners. So I want to close this whole keynote out with 2 more slides. And one thing is, I just tweeted this out recently. The graph you see there is really fascinating, and I really feel good looking at it, just because those are basically all the shots which go out within a period of day, and that was happening on Friday. So yeah, I mean, we don't have to stop deployments after 12 p.m. And yes, historically this was never possible at Pinterest, but today this is how we're doing things at Pinterest. And finally, I want to do a plug to the talk which is happening today at 1:30 by 2 of my amazing engineers who are here somewhere. Rainey and Jasmine are going to be talking about how we productionize Spinnaker at Pinterest and how did we enable what we just saw, the amazing stats of overall deployment growth at Pinterest. So with that, I'd like to say thank you for the time. This is an amazing community. We're really excited to be part of this. Right.
Good morning. All right, yeah, so as Rosalind said, I'm the GM for site engineering at Iterate, and all that really means is I'm responsible for the technical, all that really means is just the technical strategy and architectural direction for our internal platforms. New Relic, as many of you probably know, is an observability platform. And those of you who don't know, what that means is that we are a SaaS that absorbs the outputs of observable systems, so metrics, traces, logs, events, you name it, and we allow you to do interesting things with it, alerting, dashboarding. We're doing more and more AI functionality, and we're just helping make sense of all the data produced by your systems. And currently we're ingesting 1.3 billion events per minute, which is quite a lot. It's like 22 million per second. So we manage quite a large infrastructure. And rather than giving you even more boring biographical information about myself, I think it's more interesting to look at kind of where my CI/CD journey began and see how that's how things have evolved, but also how the themes have stayed consistent over the years with the themes that Isaac talked about in his talk. So when I went to look for screenshots for the Flickr deploy system, I was actually really excited to see that the talk that Flickr engineers gave literally 10 years ago about doing 10 plus deploys per day of our, at the time, PHP monolith. That talk is still up on SlideShare. The URL is really long, but it's much easier to find it by just Googling. And so if you want to go check that out, I think it's just kind of interesting to walk down memory lane. So in 2009, things looked like this. This is how we deployed the monolith. Flickr, by the way, was only ever about 12 to 15 engineers during this era. And so a lot of the tooling was homegrown and pretty simple, but it got the job done. And so if you look at what's at the top is something familiar, right? It's just a log of what's been deployed and when, but also there is a checkbox. And you might say, why would you need to chat in your deploy log? And you need to chat in your deploy log so that you could tell people not to deploy it. The way the system worked is things went from, we called it trunk at the time, to staging automatically. And then you went and looked and saw if anything was broken on staging. And if it was, you went and said, whoa, no deploy please, because if someone deployed, those problems would be copied from staging to production. And I don't know, I just think it's really interesting to watch the progression of these UIs over time. So fast forward 10 years, I'm at New Relic now, and we're still deploying all the things, but all the things look very different. New Relic is just over 500 engineers, and until very recently, we literally had more services than we had engineers, right? So microservice architecture has introduced a lot of advantages, but also a lot of complexity into your tooling. And so We give our engineers a lot of freedom to do what they need to do to solve their problems. There's not a lot of restriction going on what language and platform you use. It's not a total free-for-all. You have to kind of make a case for it. But in the end, we end up with a pretty, it's not a PHP monolith. It's 500 services in as many as 8 different platforms. Fortunately, it's all in containers, which makes life a little bit easier in terms of operating this system and in terms of building tools for it. But there's still, the tools really have to nail it, right? Because otherwise it's just impossible to manage all that complexity. So in 2016, we rolled out a Mesos Marathon-based platform to support our application and service developers, right? Folks that own most of the services that are stateless, that are either HTTP or network services, or they're queue consumers. So to serve that audience, we introduced Mesos Marathon, and it worked really well, honestly. It's still up. It's still most of those services still run on that platform, and everyone that's moved on to it has been super happy. However, as we looked at what if the application is a homegrown multi-tier distributed database, right? Which is what powers the core of New Relic's analytics features. It's called NRDB. If that's the case, deploying traditional deploy strategies just aren't sufficient, right? It's just too complex. There's too much state, right? You have to manage storage. If you're trying to grow the cluster, you have to move data. If you're trying to do maintenance, you have to make sure that that data can be served from somewhere else. And we just could not handle that complexity using Mesos without just too much fragility. In the meantime, to serve the customers that we did get onto this platform, we introduced an abstraction layer called Grand Central. And Grand Central, the main feature of it is that it allows the service owner to declare what their service is and what it's supposed to do and how it needs to be deployed declaratively, and it's attached to their Git repo, right? It's in version control. And so you register your repo, the tool reads your description. The description looks about like this. Don't try to read it, it's just boring YAML like any other boring YAML. But it tells the system what it needs to know about deploying this service. When you feed that in, what you get back is this screen, right? Which, again, has all the same things on it, but obviously people have invested a lot more effort into making it look nice than the screen that we worked on at Flickr. But it's got all the same stuff, who deployed what deploys failed, and what changes were deployed. But it's also a lot more complex because, again, we're now looking at a deploy page for one of the 500 services that we have, right? So the tool handles all our environments, all our different services. It's honestly pretty advanced, but it was built with Marathon in mind. So when it came time to serve the other 20 plus teams that were still just rolling their software directly onto hosts, right, and just interacting directly with hosts, whether it's through scripts or something like Ansible, we realized we had work to do. And so that's when the what I call the 2020 plus internal platform comes in. Actually, it's already in production, but we're still rolling it out. It's a multi-cluster Kubernetes platform where we're splitting things up both by functionality and also by customer cohorts to give us more reliability, more ability to experiment, and just being able to, and the Kubernetes bit is what enables us to actually serve the more complex use cases. So instead of just saying, hey, let's migrate all these happy application and service developers off of Marathon into Kubernetes, we said, who cares? They're already happy. We could literally make it so that they would click deploy one day and it would end up in a different orchestrator. They would not care. Let's target the folks we're currently not serving at all. And so we did that, and where possible, we're using stateful sets for our really complex use cases, like the aforementioned NRDB, which is kind of looks like Hadoop if you zoom out far enough, but isn't really. We're using CRDs and operators. And for those for whom this is the first Kubernetes-related event, and you maybe don't know what that is, a CRD is a custom resource definition. It's just a way to teach Kubernetes about a new now. And I say just, it's actually incredibly powerful. What that allows you to do is it allows you to write code that runs on the Kubernetes control plane that understands, new YAML that you passed to Kubernetes that it previously would have errored out on, and act on it, right? So you can say, oh, well, I have this NRDB cluster, Kubernetes knows what that is. I need to grow it, Kubernetes knows what that means. That's really, really powerful. But you need to deploy all that. right? So deploys look very different in this world. It's not just, oh, deploy the new version and make sure it works correctly. It's potentially deploy, new version to part of this particular tier of this complex system. It's potentially, run the data preload for this particular host before we deploy machines on it, right? Before we deploy code on it. So we have to support all that. We still want visibility into what's happening there. We still want the same features like audit logs and apples and all that. So Spinnaker, fortunately, has all those, right? So rather than try to build all of that into our own system, we said, let's embrace the community. Let's go where the rest of the Kubernetes community is already going. Let's take advantage of that. The highlight for us is Canary support for NRQL. NRQL is the language that you use to speak to NRDB. It's what we use to get metrics out of it. And you can tell Spinnaker a query, right? You can make it ask NRDB whatever you want. It's not just based on error rate or anything specific. Whatever events or metrics your service produces, you can interrogate those. And the community has delivered, right? We've really experienced that. We've been able to merge pull requests really quickly to adapt Spinnaker to our environment. The onboarding has been great. And now in 2019, boring, right? Just another Spinnaker screen, but here we are, right? Here's a bunch of production services deployed using Kubernetes. Using Spinnaker Kubernetes. We still have work to do. We would like to make Spinnaker understand what CRDs are doing a little bit better. And we still have to develop new patterns for new use cases, right? Those deploys look very different. We don't want every single team on the stateful service defining their own pipelines from scratch over and over. And when they do, we want to give them guardrails, right? We're still very early in this process, and we're still trying to figure out exactly how to get users to be able to do experimentation, but do so safely, still do canaries, still do proper validation, etc. I'm super interested in this topic. Obviously, like everybody else on the planet, we're hiring. So please come talk to me if you'd like. Here's my email address and LinkedIn. And thank you very much.
Richardson. Again, I'm a staff DevOps engineer, and I recently took on some of the responsibilities as a team manager as well. I'm with the Sony PlayStation Network locally here in San Diego. So the last couple of years have been pretty exciting for our DevOps team as we've migrated our network services to the cloud. I'll tell you a little bit about that journey, the technology, the people, and where Spinnaker fits into the story. And forgive me, but seeing as how we're carrying a nautical theme with Spinnaker and Kubernetes this week, and we are in San Diego, not a bad sailing city itself, I'm going to sprinkle some nautical references in as well, so just humor me. All right. So, our voyage to the cloud. Last summer, in 2018, we completed our voyage to the cloud. We lifted and shifted about 100 services on our PlayStation Network Commerce and Account Space from our data center to AWS. Today, most of our production workloads are running on AWS EC2. We've got almost everything in this code, but we're still working on getting those last few infrastructure pieces codified. We're running our continuous integration and continuous delivery deployments on our Jenkins pipelines. We are using HashiCorp Packer and Ansible to create AWS Amazon machine images, and we're deploying immutable images to EC2 with our in-house built CI/CD toolchain, which coincidentally is also named Hyperloop. And so behind our Hyperloop, we've got a mix of tech behind the scenes with Jenkins files, Java, Python, AWS Lambda, CloudFormation, code pipeline, etc. So it's a bit of Rube Goldberg, not unlike what Andrew from Google described last night in his keynote. But hey, it works, and it works pretty well. We're deploying 300 to 500 automated deployments a day in our development, integration, QA, and external partner integration environments. For now, we've got some manual gates before delivering to our production and customer network, but we're looking to streamline that. So yay, we're in the cloud. We made it through our peak holiday 2018 period. Now it's January 2019. Go team. All right, what's next? So remember, this was a lift and shift solution. We're hearing a lot about cloud native. We're not cloud native, but it sounds pretty cool. We want to be cool too, so let's dive into containers. Let's do it now. We need containers, we want Docker, we want Kubernetes, and since we're already on AWS, let's use Amazon's Elastic Kubernetes Service, or EKS. But how are we going to deploy this? How do we get to that lush green tropical island that is cloud native? We know we have a lot to learn about containers and running on Kubernetes, and we don't have a lot of time or interest in building our own deployment and operations tool. And we heard before, we wanted to take advantage of the larger development operations community. So, hoist the Spinnaker. So we draw up our plans for our voyage, and it looks a little like this. We've got Docker, we've got Helm templates, not only for our cube deployment manifests, but for our infrastructure as code as well. We'll templatize our CloudFormation with Helm and run it all on Amazon's EKS. As far as our Spinnaker installation goes, we've got Spinnaker infrastructure as code, we've got Helm charts, CloudFormation for EKS infrastructure stacks. We're using Halyard and Spinnaker config files maintained in Git. And because we're comfortable with Jenkins, we are using a Jenkins pipeline to stand up our Spinnaker instances. One of these days we'll get around to using Spinnaker to deploy Spinnaker like Airbnb does. That sounds pretty cool. So we have Spinnaker integrated with our security infrastructure. We're leveraging HashiCorp Vault for our secrets management. We've got LDAP for our Spinnaker user management, and Okta for our multi-factor authentication. So we've pretty well productionized our Spinnaker instance. Within Spinnaker, we're using the manifest-based Kubernetes V2 provider. We've got Helm packages baked with environment values override, and you have manual judgment canary deployment pipelines. And we've integrated our Spinnaker with our Jenkins CI/CD pipelines via webhook triggers to coordinate parallel deployments to EC2 and EKS. And as we migrate our services, there's periods of time where we're running both on EC2 and EKS and Kubernetes. So what's our deployment strategy? We want to establish our own beachhead on the island of cloud native by migrating a pilot service, a single pilot service to EKS. We chose our PlayStation Network accounts and entitlement service. It's a critical piece of our infrastructure. We're serving 20,000 transactions per second, so we're going all in. We're doing this for real. All right, so enough about the technology. Let's talk about the people. As of January this year, our team didn't have much experience building containerized services. We had little to no experience with Kubernetes, no experience with EKS, and absolutely no experience with Spinnaker. We wanted to get this pilot done quickly, so we formed a Liger team. And in case you haven't seen Napoleon Dynamite, a Liger is a cross between a lion and a tiger, and they're pretty awesome. So our Liger team was composed of engineers from development, DevOps, Ops, cloud infrastructure security, and architecture, and a few program and product managers thrown in for good measure. We all worked together in our Liger den to get this pilot done. We wanted to move quickly. We had no luxury of building out our CD pipeline on Spinnaker in dry dock, if you will. We were building it, our ship is C under load from our continuous service deployments. Needless to say, we made some mistakes along the way. We learned, we iterated. We started with a very basic Spinnaker installation, but we were able to keep it stable. And because we built our Spinnaker infrastructure as code from day one, we could spin up one Spinnaker instance, hand that off to our developers and our operation team members that could use it to deploy, while in the background we had a couple other Spinnaker instances for our own continued iterations and building out and productionizing Spinnaker itself. So by the end, and just a couple months ago, we had our Spinnaker installation process down to the point where we could stand up an entire production instance from source and immediately deploy services to production with that instance. So during our rapid service deployment and development and deployment iterations, our DevOps teams use Spinnaker to deploy at will, and we had repeatable manifest-based deployments. Spinnaker gave us visibility into pod health, container, and application startup logs, which was really important as we were learning to build, deploy, operate our cluster in Kubernetes. We had simple, repeatable deployments. Again, developers and ops teams deploying at will, and we had automated deployments synchronized with our EC2 and EKS platforms. Team members were able to build and tweak their own pipelines as we all figured out what our pipelines needed to look like. And in summary, in the course of 10 months, we learned to install and operate Spinnaker on EKS while at the same time using Spinnaker to deploy and operate our service deployments on EKS. We plugged Spinnaker into our CI/CD pipeline to allow continuous and synchronized deployments to both EC2 and EKS. So now we've got our entitlement service running in production. We've got it running both on EC2 and EKS, and we can dial traffic back and forth. This is really given us a safety net and the confidence to continue to tune our Kubernetes infrastructure, do memory parameter tuning on our pods, worker node instance types, scaling, etc. So our next steps, we've got work to do to build out continuous deployments with Spinnaker. Of course, we want to build pipelines as code as we onboard more services and give developers pipeline templates. We want to scale that well. And over the next several months, we've got various waves of onboarding new services to Kubernetes with Spinnaker, and we plan to ship a lot of those 500 daily deployments to Spinnaker. So thank you, and as I live in San Diego, welcome to San Diego. Hope you get outside and get a few minutes to enjoy the weather here.
I'm here to talk to you today a little bit about how we leverage shared libraries, config generation, and how that dramatically improves speed, safety, and adoption at Discovery. So she just gave me a quick intro, so I won't spend too much time here, but my name is Stephen Garlick. I started at Discovery about 4 years ago, and my title is a lead cloud solutions engineer. I have a focus on cloud and container-based solutions, but overall, anything we can get our hands on, we look to improve. To give you an idea of what we support today, we have many globally distributed teams, and they manage things such as ad sales, content delivery, rights management, general internal IT, broadcast systems, security teams, video on demand, and live streaming. We deploy across both Amazon, GCP, VMware, and currently Kubernetes in most cases. And we currently run about 150 services in production, running in numerous languages, but primarily Java, Node.js, Python, and some Go. We also run a number of open source and vendor tools. Relevant to this would be HashiCorp Vault, running Kubernetes itself, Armory or Spinnaker itself. So where we started, when I first started 4 years ago, the developers were looking to shift towards a microservice architecture. But as you can see the list here, we had basically every problem that you could have. Like, to set up a new service, it took days, weeks, worst case months is what I saw. Deployments were extremely error prone. They were done on weekends, they required downtime, they required dozens of teams to be involved, DNS teams, somebody running database or database migrations, someone else going grabbing an artifact from Jenkins and throwing it into JBoss or Docker container. The environments were super inconsistent. Like, you had no idea what you really ran in your test environment was actually going to work, and a lot of times it didn't. And we had tons of tools, but low adoption rates. Like, we had plenty of APM tools, but one guy was using it for managing, 60 applications that he managed for developers. We wanted to get a lot more people in there other than our single person. So we had a few goals when we started. We obviously wanted to get away from weeks at a time to build a new service and to make it very quick. So we are aiming for 10 minutes from someone running a job to a help check capacity in production for that application. We wanted a full, complete configuration for production and all our environments to find it and Git. So we were looking just for a simple application with a health check, APM configured, all secret management set up, a full CI/CD pipeline for it, all sorts of networking, ingress, DNS certificates, and so on. and as well as monitoring, logging, metrics, alarms, dashboards. Ideally, we want all those done by default. And then with all that, we were hoping to gain quick, safe, immutable deployments where the flows through the tools were identical, whether it be Terraform or Kubernetes, the experience would be the same. We want to get the environment consistent and easy to update. And then lastly, we want to get ease of use. And we were aiming in the terms of making it so our EVPs could run this job and set up a new application. And they probably had no idea how to update it after, but they could at least start one. So we initially started with a bunch of building blocks. So we primarily chosen Terraform and Kubernetes to define all of our service components. So that gives us, everything that's related to this service is going to be defined in Git for us. We use DB files from Armory and Jenkins files to find and discover those configs and deploy them. Obviously, we want to get as much as possible of the configs stored into Git. 100% ideally, I'd say we're probably around 95% for a lot of things. And then lastly, once we do all this, we want to make it really easy to update and maintain existing services. So we're able to use reusable code to ease the generation, enforce those standards, and apply those updates. So in this case, that would be a Terraform module, that'd be a Jenkins shared pipeline, that'd be a Dingy template, managed pipeline templates E2. Obviously, you don't have to use any of the tools we're talking about here, as long as they support some form of that, then you're good to go. So now that we have these building blocks in place and we can kind of define all the stuff we want, it's still relatively slow. We're not in the weeks to months range, but we're in the hours to days range. We still have a couple of teams that need to be involved to set up the service, and more or less people just end up copy and pasting. It's like, all right, we're set up a new service, copy and paste these modules, deploy them, and we thought we could do a little bit better than that. So that step was to tie it all together. We have everything to be able to find in Git, so we decided why don't we just generate Git repos when we create a new service. So I just have a really small flow here. Starts off by a user, could be a developer, I said, could be a VP. We've had VPs run it to test it out. They run a job on Jenkins, which generates a couple Git repos on our GitHub. Those have Jenkins files and DB files in the repos, so you can see here, one for the service, one for the manifest, one for Terraform. Those all predefined, just what we said before. Number of times, devs put also all the time for new apps, they don't have health checks, so we put health checks automatically in place. They come to us and they're like, well, all our secrets are just checked into Git in plain text. We already have them all in place so that we can get them to put them in there. We have our Kubernetes manifests, we have our Terraform stuff. So the Kubernetes manifests are just what we mentioned before. It defines our ingress, it defines either public-private certificate, defines network policies, it defines anything that Kubernetes can manage. So once they get that off and those repos are created, they automatically get picked up by Jenkins or Spinnaker or Armory, in this case with the DB files. So you can see here, those get picked up and they automatically go through our build pipeline, which is kind of simplified here in just the form of Jenkins pushing to JFrog, or potentially a Git webhook going to Spinnaker, or even Jenkins just firing a webhook up at Spinnaker. So you can see for our services, Jenkins builds those, publishes the Keynote or JFrog. For our Kubernetes manifest, Jenkins also builds, validates some stuff over those, which eventually triggers Spinnaker with a webhook. And then for Terraform, we're just using Git webhooks there. So at that point, everything's in Spinnaker. Your devs don't really need to care about the center piece here. They care about living in GitHub, and they care about living in Spinnaker itself. And you can see the actual deployment now, basically taking two paths, whether it's a Kubernetes managed piece of the service or a Terraform piece of the service. And you can see there on the side, every image there is something we either use currently, or no, everything is stuff we use currently deployed by either Kubernetes or Terraform. So, and if you can't find a Terraform provider to support a tool you're using, they're not that difficult to write, and there's plenty of documentation around that. So what next? We've improved a lot of things, but we're still extremely immature. Like, we started from the worst possible case, and now we're into a case where we finally can actually start doing interesting things. So we do have a snowball effect. Now that things can happen extremely quickly, we can continue to build out modules, libraries, take advantage of new features as developers want to use canary analysis, and we'll already have all the metrics in place and so on, so we can get those in easily. And when we update that, it'll apply across all our applications. We want more initial config options. Like I said, we're in a very minimal state of, do you have a health check? Do you have config? Do you have graceful shutdown? But we can go even further and say, all right, well, you want a Postgres database? All right, we'll spawn that, automatically store that configuration in Vault, and your app already have pre-configured to pick that up. We're looking at ephemeral test environments. So because everything is in Terraform and everything is in Kubernetes, we can easily make a pipeline that a developer can trigger to run all these templates, execute some tests, and tear it all back down. And lastly, we kind of tricked all the devs into adopting our stuff here. We put everything in place so they didn't have to know anything at all initially, which was really the biggest barrier. Like we have, tons of tools. Like we use New Relic, and we use Splunk, and we use more than I can name here in like the little bit of time that I have. But yeah, we need to train them better on them because we need to be able to have them update those and really use them. So that is it, and thank you.
So we have a lot of use cases that we have on New Relic, Airbnb, not just in the keynote, also across the conference, right? Home Depot, Netflix, etc. Right? They all have one thing in common, and that's obviously how to keep Spinnaker up and running with the highest SLA that you can think about, right? So I'm going to jump directly on. Before you actually think about the production, you have to secure the system, right? And one of the most important things that we're trying to introduce in our deployments at Salesforce. So first of all, we need to have authorization and authentication. In a couple of sessions, I was just listening to people say people jump into Spinnaker, they can actually mess up with other people's application, and that's not good. Obviously, we need to control that. We need to enforce fiat, and we're working on those things. We need to keep track of all the configuration changes, right? We need to know exactly who made the change, and we want to drive that configuration as a code. We don't want to go and jump into the system and make changes and how that actually deploy and all those kind of things. We want to make it be a code. Encrypted communication between microservices. This is one of the hard requirements to go to production. We have to have NTLS enabled. Obviously, we have two endpoints, the UI and the API. They need to be TLS encrypted as well. So this is practically one of the very first things that you do, but it's important to actually highlight it in the session. We need to encrypt all the data in the rest, whether it is customers' information or not, because we're talking about buyback, we still need to do encryption on those backends. Your secrets, right? All in plain text, and I'm gonna repeat that part, but yes, don't keep the secret there, so we need to put in secure card, vaults, or whatever other KMS system that you wanna use. My favorite part, OSS vulnerabilities. So I had a lot of people here running Spinnaker already in production. I have wonderful news for you. So our scans reported 60% of critical vulnerabilities, 35% on severe, and 5% on moderate. So this is super critical to start fixing all these vulnerabilities. We did this test with our previous version of Spinnaker, I think 1.15 or 1.16. I need to double check. But there's still so many vulnerabilities that we need to get all over. And finally, everything that is being produced needs to be signed and validated, right? So we are making things, we're actually creating new artifacts with Spinnaker, they need to be verified. Now, once it's secure, which seems to be very simple, right? Now we go to the production readiness. It's very critical to have not just one Spinnaker deployment. You need to have a dev environment, you need to have another kind of like performance testing environment, etc., right? You don't want those environments to be different. You don't want to a service engineering team to go over the whole deployment and their configuration, and then you have one deployment that looks like an apple and the other one like an orange, and you never do things in the same way. So you need to have a way to do automated and independent deployments. And guess what? Spinnaker is just a bunch of microservices with a bunch of backends and other things, and they need a way to be CI/CD as well. So why not to have Spinnaker with a Spinnaker? So you can actually use a Spinnaker to deploy your Spinnaker. And that's really something that we are doing, and I have a beautiful slide for you. Centralized monitoring and logging. If you will end up having more than one Spinnaker instance for any reason, so crazy things that you want to do, you want to centralize all those things. You don't want to go to 10 different dashboards and looking so crazy, and obviously it's going to help to do any kind of issues that you have in production. How do you define your SLA, right? We have all these microservices, we have replicas for all of them. One is down, is that an outage? Or is just a performance degradation, or is a data loss? So there's a lot of things that we need to do in this field. I mean, it's great that we're coming together as a community, but it's obviously a lot of field, or greenfield, that actually we need to look into. I'm going to repeat this because this is also for operation readiness, right? Configuration as a code. You don't want to have someone to mess up with your Spinnaker thing, right? Besides the LT of N, you need to keep track of all these changes. We need to create runbooks, playbooks, troubleshooting guides, or any one of fancy names that you want to put for all those kind of things. Sometimes there is a different teams who actually put these things together, development, testing, and SRE teams. So they need to understand what they're doing, so you need to write those things. We are deploying the same thing all over the place. Why not start sharing all those things together as a community? And what about HA, reference architecture, and DR plans? Where are they? So I think that one of the big goals for the next Spinnaker Summit is to talk more about these kind of things. And I will hoping to get a little bit more views on the DR plans for the next summit. Now, this is actually our pipeline that deploys Spinnaker. So basically, it's a very simple pipeline because we deploy an EAKS, and then on the top of that, we actually have the Spinnaker running. Now, we're going to talk a little bit about Spinnaker at Salesforce, and I'm going to use a little bit of Vito's thing. So, twist and shout. We have active members reporting and triaging bots. This is very important for us. We can work it out. Mostly an operator role, but supporting new features. With a little help from my friends. It's a community, right? So, becoming community leaders, not just followers. We want to participate in future development. Not just testing things for other people. Come together. Active representation in security, Kubernetes, and the SIGs. We have Charles Lane, which is an amazing guy, and we have Helene to actually participating in these two SIGs. Let it be. I would respect the community decisions. We want to lead, but we also respect what's going on here. So that's super important for us. And all you need is love, and that's basically just because I love that song. So, I'm going to conclude with a call for action. This is a call for action. You operate POC, Dev, Pro, whatever is Spinnaker? Yes? Do you have a love relationship with Cloud Driver? Yes? Let's join forces. So, yesterday I made a PR to actually create an operators ops SIG. This is a PR, so I'm recruiting people to actually join this effort. We actually could make Spinnaker a super robust system if we join forces. So this is my request for you. Thanks so much. If you didn't attend Chuck session yesterday, it was amazing. He actually live demoed the book and troubleshooted the Spinnaker, and in actually 15 minutes, Jim Vergara is going to desmythify everything about the image and baking. So I really encourage you to join those things. Thank you so much.